Hello, I'm Neeraj. Today I will explain the concept of Neuro-Symbolic AI. So we will use the concept of Neuro-Symbolic AI and develop a very simple toy example for stock predictions, multivariate stock predictions. Uh, but before going into the detail, first we will try to understand that what is Neuro-Symbolic AI. Actually, Neuro-Symbolic AI is not a new technique. Early, if you Google search on about those techniques, you will find that there are some papers, lot of papers, not just some, during 1950, 1960, 70. But again, people started using neurosymbolic AI with generative AI, with deep learning architectures to get better results. So the major thing is like what it delivers to the our approach of deep learning. So it gives things like explicit reasonings, logical inference. So these kind of things of symbolic AI. So these kind of things it adds to our deep learning architecture, which enhance the quality of the solution. So this hybrid approach generally limitations of purity of statistical or rule-based AI offers both explainability and adaptability. Now there are some basic factors like why we use neurosymbolic AI, because it overcomes the black box nature of deep learning, enhances the reasoning and logical inferences, improve the sample efficiency for learning from structured data, enables generalizations beyond the training data. Now some mathematical functions. What are the things that we use? For neural network, you are already aware of different kinds of neural network architectures, gradient based reasonings, transformer based architectures. For symbolic logic, I think symbolic logic is also not new. So first order, second order logic, you already aware of those things. Knowledge graph and structured knowledge representations. There are so many different ways to represent the knowledge. And again, Bayesian reasoning, Bayesian probabilistic reasonings, Bayesian networks. So I think people are aware of all those things. So these are comes under symbolic logic. So in the neurosymbolic AI, we try to extract such kind of symbolic logic from the data or from external sources and add those informations with neural network architecture like this in this hybrid model. So total learning or total loss functions depend upon the loss comes from the neural network architecture and symbolic logic. Again, graph neural network also provides an effective way to integrate the symbolic rule based learning with graph neural network architectures. So what are the different ways to combine the systems? So first is like a tightly coupled, loosely coupled, modular approach. In tightly coupled, you generally attach the neurosymbolic reasoning from starting to end, means a complete embeddings. In a loosely coupled, you just to take a part of outcome of some neurosymbolic reasoning and then utilize it in deep neural network architecture. In modular, like you can combine the use of neural network and symbolic components based on your requirements dynamically or through some some other ways. It generally improves the explainable techniques and bridges the gap of neurosymbolic logics. Again, some recent research advances and its applications. So I will try to prepare tutorials on these topics as soon as possible. So for example, one is like a neural lambda calculus. It integrates the deep learning into logical computational framework, DeepMind's alpha geometry. It uses neurosymbolic AI for complex theorem proving. This is very important. IBM's neurosymbolic AI, it advances the explainability of AI driven decision making system. Next is neurosymbolic reinforcement learning. It enhances the static decision making in dynamic environment. So here is the summary of some application areas of neurosymbolic AI. First is natural language processing, semantic parsing, symbolic reasoning for question answering system, computer vision, scene understanding through neurosymbolic and integration, visual reasoning, healthcare AI, symbolic AI for medical diagnosis, neurosymbolic system for drug discovery. This is also very important, and both are very important because a lot of companies and people, universities, organizations are actually focusing on this area. And next, which is a highly demanding research area, is automatic theorem proving. So here you can see that complex theorem proving DeepMind's alpha geometry that is already available. So later we will prepare the tutorial on these topics also separately. So these are the references. You can refer those papers or articles to go into the more depth. Now I will go through a working example of on algorithmic trading for this. So first of all, I will just explain what is the uh, actual task that we are trying to achieve through this example. So in this example, what I am trying to do, I have just generated a multivariate stock forecasting data. Multivariate means I am forecasting the value of two stocks two times a day based on some input features. Now, what are the role of symbolic reasoning or symbolic AI here? If you just use the data for stock forecasting and forecast the values of stocks, then it will be just like a time series forecasting. But symbolic reasoning adds some values. Generally, what happens? Stock market is a highly volatile area. So, what we can do? We can select a lot of informations related to company, related to government policy, related to some other changes which are directly or indirectly affecting the forecasting price or forecasted value of a particular stock at a particular time. So what we can do, we can collect those informations. But here, instead of collecting, I just prepared a dummy data. We just filled some sentences about stock A, some related to stock B, and save it here. So here you can see that for stock A, we consider that this is a toy information that we collected for stock A data. Now I will go through the basic algorithm. So our algorithm will start from the first part. The first part of the algorithm is to use some large language model. For example, I have used the Llama 3.1 and Grok. I have used the Grok API key, and after that, for both stock A and stock B, I fetched the data from the disk. That is, I am just reading this data to memory, and after that I consider this data as a context and add one question. The question is like calculate the sentiment score in the range -1 to +1 for stock 1 and return only number and nothing else, because generally it happens that large language model returns a lot of other string value also. So that's why I have written. Similarly, we stored the information related to second stock B, in context 2 and added the same questions like question 1 I have added, like calculate the sentiment score in the range from -1 to +1 for stock 2 and return only number, nothing else. Now by combining both, I have prepared the prompt. So for stock 1, the prompt contains the context and questions, and then it generates the answers. So prompt 2 again contains the context and then question. After that, the next task is to extract the sentiment score. So for that, we take the input prompt, apply the call the API, Grok API for Llama 3.1, 8 billion parameter instant model, and after that it generates the response in the form of sentiment. Now I have added some regular expressions. Actually what happens, several times the large language model generated text contains some string and other impurity also. So to just extract the sentiment value, I have added this regular expression. So here you can see that LLM output 1, LLM output 2 actually contains the sentiment score. Now the next part is to generate the stock data. Now to generate the stock data, I have taken the data for 180 days, mean 100 bit and 200 covariance. I have taken 1 to 0.5 and 0.5 to 1 for outcomes, and then random seeds we have taken 42, and then stock data. For that stock data calculation, I have taken multivariate Gaussian with mean 100 to 200. But generally what happens, stock data is highly means random or fluctuating kind of data, or bias. Sometimes it may be biased data also. So maybe multivariate Gaussian may not properly imitate the stock data, but just for simplicity and for explanation purpose, I have created this data. And data date range is 2024, 1st January and 1st. And after that, we convert the data for I transformer. Actually what happens, actually in time series forecasting, generally we can use LSTM based model, transformer based model, I transformer based model, Mamba based model. But these days I transformer based models are actually performing very good. So I have used the I transformer based model, and for that we just made some changes in the training data to transfer it according to that format. And after that we prepare the training, we prepare the just converted the data into like time series forecasting data. And after that we took 80% of the data as a training data and 20% as a test data. And after that, here you can see that I have defined the I transformer encoder. I have just tried to develop a very toy type of very simple kind of I transformer block. So it contains convolutional 1D architectures. Filters is equal to head size is 64, kernel size is equal to 1, number of head equal to 4, activations ReLU. And after that we took the multi-head attentions with key dimension as a head size, and number of heads is equal to that we have taken 4. And then we took the dropout, and after that again we took the layer normalization attention output, then we took the dense layer output, and then apply some residual connections and add the value. And after that dense layer, dropout layer, again dense layer, and then dropout layer for the computations part. And after that again we return it, it's a residual part. Now we take the input shape. Now this is the final code for training. So inputs are there. Now we call the transformer block with that input. Then we take the global average pooling layer and then dense layer 2 for the just two forecasting, like for stock 1 and stock 2, or stock A or stock B. So we call the model, we compile the model, mean square error as a loss we consider, optimizer Adam. And for model fit, I have taken 20 epoch, batch size 16, validation data I just consider text data as a validation data, but in a real practice you can change it, you can prepare a separate validation data, you can separate it from the text data. And after that the main part of this algorithm is like a neuro-symbolic adjustment. So it is like a forecast or input prompt. So this neuro-symbolic adjustment actually means work on the forecasted value, because it is a loosely coupled kind of architecture, or you can say that it is a modular architecture. Like we dynamically select that from where the model means symbolic AI can make some changes in the results. So it extracts the sentiment value and then calculates the volatility factor, like how volatile a share price can be, based on these sentiments. So this volatility factor we have calculated, and then apply the sentiment symbolic adjustment. So symbolic adjustment will depend upon sentiments plus volatility factor, and then adjusted forecast we have calculated, and then we return it. Now what happened? We take the test data and prepare the results. In that results, we also, so we will just try to run this. So here our system is very simple. Just I run this system, this code on a just 16 GB RAM system with i7 core i7 processor. So here you can see that training is complete, uh, and it is generating started generating the results. So here you can see that for stock A, the raw predictions was 100.31 and adjusted was like 106.83. So it is 0. So it is like 6.51% adjustment came from the Neuro-Symbolic AI. So this way it creates all such kind of adjustment. So sometimes it increase the share price, sometimes it decrease the share price. So based on the change of the here, what I did, I have taken one time, I have taken the Neuro-Symbolic help to adjust the data value. But if you have a sufficient settings to directly fetch the data from network based on the changes in the news articles, company policies, or etc., then you can change and dynamically update your symbolic reasoning part and apply it here. Similarly, you can also update the volatility factor. Generally, volatility factor should not be so simple. This is just a toy example to explain the symbolic reasoning. That's why I have taken such simple adjustment. So now the code is running. So once the code run will complete, it will save the entire results into CSV format, and then it will show that what was the forecasted actual forecasted value for stock A and stock B, and what are the adjustment made by symbolic reasoning, and what percentage of adjustment made by those symbolic reasoning. So I feel that it you may be easily able to understand what are the role of symbolic reasoning in the algo trading based forecasting. So here you can see that the results are complete. So stock A raw value is this, adjusted value is this, percentage change is given here. Stock B raw value is there, adjusted value is there, percentage change is there. So for each such stock, the details are given here. So based on that, the main aim of this experiment is to showcase that how symbolic reasoning or symbolic AI can actually make changes in the results. So I hope that you would have enjoyed the entire tutorials. So thanks for watching.